Now let's talk about shapes of distributions and what they have to do with central tendency. We're going to start with an example of how people can be bamboozled by statistics if they don't know something about how central tendency works. So what I've got for you right now is a graph, and it's salary in thousands. On the x-axis, we have the categories of salaries, starting at $15,000 a year and going up to $109,000, $110,000 a year. And on the y-axis is the frequency. So it's the number of, maybe it's the percent of people or number. I'm not exactly sure. But let's just say, hypothetically, that this is a company that is presenting their salaries, or this is the salaries in a certain company. And the company wants to make it look like they pay their workers more than they actually do. And as we look at this distribution, we notice that it is a skewed distribution. It's not a normal distribution. It is a positively skewed distribution, meaning most of the scores cluster on the left side. It has a right skew, meaning these scores out here are going to pull the mean away from what is really the true center of the distribution. But if I was a company and I wanted it to look like I was paying my employees more than I was, I would present the mean salary. Now, why would I do that? Well, the mean salary is going to be the balancing point. And so it's going to be higher than the actual, meaningful center. So the mean will probably, maybe it'll be 60,000 or something like that, because all these extreme scores are pulling the mean over this way. So in that way, I would be sort of being duplicitous to say the average salary for my company is 60,000, whatever. But you know what? That's not really where most of the people are having their salary. It's not where the modes are, for example, and it's not where the median is. The median is going to be much closer to maybe this big chunk here. So in this way, the mean is misleading, and just keep this in mind. The mean is misleading when you have skewed distributions. It's not meaningful, but sometimes people will use it to sway you towards their arguments. So you be very careful when somebody's presenting the mean of anything. You need to ask, is this a normally distributed group of people, or are most of the scores clustered on one side? Okay, I'm giving you something, I'm arming you with something for when you go out there and you read statistics. So let's just review that the shape of the distribution and the scale of measurement are two different ways that help us to determine what kind of central tendency we're going to use. In other words, we want the central tendency that's going to be most representative of the distribution. We want it to be real. We want it to mean something, right? So let's take a look first at the mean. We use the mean with the scale of measurement for interval or ratio data. We can't use it for ordinal, and we can't use it for nominal. If we did that, we'd be completely in error. So we can't do that anyway. So we know that we have to use this type of data. It is not appropriate when we have those extreme scores, like I mentioned, the skewed distribution. These are kind of one and the same. And it's also not appropriate for ordinal or nominal, as I mentioned. So when somebody is trying to use the mean with any of these things, you need to be very dubious. So the median is appropriate when you do have those extreme scores. It kind of accounts for it. It kind of takes care of those extreme scores and kind of disregards them in a certain way. You use the median when there's a skewed distribution, and you can also use the median with ordinal data as well. It's not appropriate for nominal data. Still, we can't use the median with nominal data. It makes no sense because there's no order to a nominal data. The last one is the mode. So when is the mode appropriate? When you have nominal data that are discrete, or when you just want to describe the shape of the distribution. And again, not appropriate with interval or ratio. You might want to take this chart, make notes on it, keep it to the side of you, so you kind of remember what types of central tendency measures can you use in different situations. We're going to talk real quick about the shape of distributions and what this has to do with the mean, the median, and the mode. So the most important thing to remember right now is that in a symmetrical distribution, the mean, the median, and the mode are exactly the same. Exactly the same. So as I look at this right here, the mean, the median, and the mode all line up in a symmetrical distribution. They will be the same number. If you have a symmetrical bimodal distribution, you're going to have two different modes, but the mean and the median will still be the same. So keep that in mind. If we have a positive skew, however, let's take a look. In a positively skewed distribution, you need to remember that the mean is higher than the median. So think of it this way. It's that mean that's pulling the tail. So when we have a positive skewed distribution, the mean is going to be higher than the median. And it's just the other way around. In a negatively skewed distribution, the mean is lower than the median. Because again, the mean is pulling towards that, or the tail is pulling the mean out towards it. All right, we're going to wrap this up by finding the mean, the median, and the mode for the following scores. Pause your computer and then come back. Okay, so here we go. We had 10 scores, and the sum of all of our scores was 37. If I add up each of these, it's 37. And so our mean then is 3.7. 37 divided by 10 is 3.7. The median is 3.5. I did that little line right here. And the mode is 3. So pretty easy to figure these things out. All right, I'm going to summarize lesson 3, but we still have one more video. And that's a tutorial video on how to calculate these, the mean, the median, and the mode using Excel. So measures of central tendency are descriptive statistics, and they're statistics that are most representative of a distribution. And the scale of measurement and the shape determine which measure of central tendency it is that we're going to use. All right, that's it for now. I will see you at the tutorial video.